Hello, we are going to be on your day 8 worksheet. Your homework is the day 8 homework. It is a video going over exponential functions and what they are. It's super important that you watch it. Please watch it because we're just going to do practice multiple choice questions based on that video when we get back to class next week. Anyway, take a minute, pause the video, see if you could rearrange these words. That way they actually answer the question being asked. So the question was, explain what a rational exponent, such as 5/2 means, and use this explanation to evaluate 9 to the 5/2 power. Now, we know that, or hopefully we remember, that all of our explanations should start by identifying what the power and the root is. And the power is in the numerator, and the root is in the denominator. So we have the numerator is the power, and the denominator is the root. The square root of 9, because what's happening here is if the power is 5 and the root is 2, you get to choose whether you want to raise 9 to the 5th power first, or if you want to do the square root of 9 first. You could do the power or the root first. The choice is yours. The order doesn't matter. And you know what? I don't know what 9 to the 5th power is. That's why this answer is going with what's the square root of 2 first, because, sorry, the square root of 9, because we know what the square root of 9 is. And the square root of 9 is 3. And then once you have 3, we use the 2. Now we have to use the 5 in the exponent. So 3 to the 5th power is 243, and that's how you can evaluate it. Anyway, with the next example, with the power to power rule, when you have multiple exponents, what you are going to do is multiply them. So what we really have here is 2 times 1/2. Now this is really 2 over 1. So 2 over 1 times, 2 times 1 times 1 times 2. If you multiply, we get 2 over 2, which just simplifies to 1, which is just x. Same thing happens for the next one. We're going to multiply our exponents 3/4 times 4/3. In the numerator, 3 times 4 is 12. In the denominator, 4 times 3 is also 12. 12 divided by 12 is 1. And then anything to the first power is just itself. The same thing happens in the last example. We have negative 1/2 and negative 2 over 1. Anytime you have reciprocal exponents, they will undo each other and just be whatever the base is. The exponents will disappear. Now, it's really important to note that both of these were negative. So if your original exponent is negative, the next exponent has to be negative as well in order for them to cancel out. And if you think about this, hopefully it makes some sense, because we have the square root of x, and we know that if you square the square root of x, it's just x. And this whole time we've just been telling you that radicals and exponents undo each other, but maybe we know, or at least now we should know, that x, the square root of x, is x to the 1/2, because the power is 1 and the root on the outside is 2. So with power over root, you get x to the 1/2. And then if you square that, 1/2 times 2 is x to the first, and that's why you get x. That's why radicals and exponents undo each other. It's because when you turn the radical into an exponent, they do cancel out because they become reciprocal exponents. You guys did have homework The only new part about the homework, because the rest was all in the video, I believe was numbers 6 and 7. So here are your answers. It is important that when you do these, I believe that was the last one. Yep. It's important that when you do these, you isolate the base first before you raise it to the reciprocal exponent. And that's why it's super important to divide by 2. And once you have just the base what's attached to the exponent, then you raise it to the reciprocal. Also for number 7, if you raised it to the positive 2 power, you were almost correct, but because you started with a negative 1/2, you had to use an exponent of negative 2 over 1. So our target is that at the end of the 42 minutes, I can solve equations with fractional exponents. Now, before we can even deal with the exponents like the video said, we are going to have to get the base by itself. What that means is we are going to have to work from the outside in, because my base right here is x. So don't even touch the exponent before you get the x by itself. And usually it is easiest to add and subtract before multiplying and dividing. Reason is, if you were to divide everything by 2, I have no idea what 3, well, okay, yeah, I do know what 3 divided by 2 is. But my point is that 3 divided by 2 is not a nice number, so don't start with division. Instead, we are going to start with subtraction because we're getting rid of the plus 3. Now we're going to get rid of what's in front, that coefficient. So we're going to divide by 2. And we get that x to the negative 1/5 is equal to 1/2. You might want to write 0.5. No, you're not wrong. But I will tell you it is easier to keep everything as fractions for this lesson. Now, because we have a negative 1/5, we are going to raise it to the reciprocal power. And the reciprocal of negative 1/5 is negative 5/1. Now, all you're going to do is go to your calculator, type in everything exactly as you see it. So we have 1/2 to the another fraction, so another alpha y equals negative 5/1. And that negative could go anywhere. It could go on the top, the bottom, outside. It doesn't matter where a negative is in the fraction. Also, you could just write negative 5 if you want to make your life easier. But the point is, the calculator tells you it is 32. And hopefully you wouldn't even need a calculator for this. The reason being is that, let's just work with negative 5. So 1/2 to the negative 5. Well, if you have a negative, negatives either cause fractions or they get rid of fractions. So because we have a fraction, the negative gets rid of the fraction and it becomes positive. From there, 2 to the 5th is 32. So a lot of these problems you can do in your head without a calculator. What is super important is to always look at the denominator. The denominator here is odd. If your denominator is odd, then you do not need a plus or minus in your answer. If your denominator is even, then you do need a plus or minus in your answer because the denominator represents a root. So remember, if you have an even root, such as the square root, the 4th root, the 6th root, or the 8th root, you need a plus or minus in your answer. But if you have an odd root, such as the 3rd root, the 5th root, or the 7th root, you don't need a plus or minus in your answer. So you always have to remember to look at the denominator to know if you're really taking an even root, to know if you need a plus or minus. And I know that's hard to remember. Trying the next one out. Let's see. We're going to work our way towards the base. And it's important that we can identify what the base is. The base is attached to the exponent. Because we have parentheses here, everything inside the parentheses is attached to the exponent. So we have to get rid of everything outside of the base. So we got to get rid of that 2 on the outside. You cannot distribute the 2 in. You can't do this. And the reason is because there is an exponent in those parentheses. So you can't just distribute 2 when you have exponents as well. Instead, we are going to divide. And 54 divided by 2, was that 26? No, 27. Now that you have the base by itself, because everything is attached to that exponent, you're going to raise both sides to the reciprocal exponent. And notice how I'm saying we're raising it to the reciprocal exponent. This is not multiplication. You're still dealing with powers and exponents, and I don't want you to say multiply because unfortunately a lot of people make the mistake of multiplying on their calculator instead of using exponents, so be careful about that. On the left-hand side, your exponents cancel out, and we're just left with 2x minus 3. On the right side, 27 to the 2/3. Now, we should be able to do that without a calculator. The cubed root, because 2 is the power, 3 is the root, the cubed root of 27 is 3, and 3 squared is 9. Or use your calculator. We have 27 to the, that is a 25. Oh, is it 2/3? Yep. There we go. Calculator tells us it is 9. And from there, you know how to solve that equation. We are going to add 3 to both sides. And then we are going to divide by 2. Now, I forgot to mention it, but up here, your denominator is an odd number. That means you're taking an odd root. You're taking the cubed root. And with the cubed root, you do not need a plus or minus. Always look to see if the denominator of the exponent is even. Anyway, our answer is 6. And you guys could check all these answers if you wanted to by plugging it back in. You can do 2 times 32 to the negative 1/5 power plus 3, does that equal 4? You could do 2 times 2 times 6 minus 3 to the 3/2. Does that equal 54? So plug it back in your calculator to check to see if you're correct or not. And now moving on to a regions question. This regions question is worth 2 points. And it says, given the equal terms, determine and state y in terms of x. And it might seem complicated of where to start, but if they're telling you something is equal, then maybe write them equal to each other. So we have the cubed root of x to the 5th is equal to y to the 5/6. Now, even if you don't know what to do, you do know that we can't work with radicals. We work with exponents. So what we're going to do is use power over root to transform this into a rational exponent, and rational means fractional. So my power is 5, my root is 3. This is x to the 5/3. And now we're going to see what this question actually wants. This will actually get you 1 point so far. They ask you to state y in terms of x. What that means is that they want you to get y equals. So we want to get y by itself. And if you want to get y by itself, you need to get rid of the 5/6. To get rid of the 5/6, you need the reciprocal exponent. So I'm going to do 6/5. On the left-hand side, right-hand side, these cancel out. And you're just going to be left with y. On the left-hand side, we have 5/3 times 6/5. Now, if you want to, multiply the fractions in your calculator, or Okay, something on the top and the bottom cancels out. They become 1. From there, 1 times 6 is 6. 3 times 1 is 3. 6 divided by 3 is 2. This is x squared, and if you put in the calculator, you would get the same. And keep in mind, you do not need a plus or minus because that exponent was odd. So there is no plus or minus. And we have our answer. Y is equal to x squared. Trying some practice if you would like, pause the video and try these problems on your own. Otherwise, we're just going to work through them. For the first one, n minus 27, all of that is attached to your exponent because of the parentheses. N minus 27 is your base. And because it is only your base and there's nothing else in this problem, you can start to already get rid of the exponent. Now, I just want to point out that when we type things up on Word, sometimes the exponents don't come out as nicely. If you wrote this on a test, and a lot of us wrote this on our quiz, you will lose points for that because the exponent is too large. Instead, what you should be doing, and I know it's hard to do this on the computer, but you want to write the exponent really small. Anyway, moving on, raising both sides to the reciprocal power. So if you started with 3/2, you're going to end with 2/3. On the left-hand side, your exponents undo each other, and on the right-hand side, 2 to the power 3 is the root. The cubed root of 64 is 4, and 4 squared is 16. Or 64 to the 2/3 is 16. You do not need a plus or minus because this is odd. From there, you're going to add 27 to both sides. Let's see, 16 plus 27 is going to be 43, I believe. Trying the next one. You have to get rid of the plus 1 first. So we are going to do that by subtracting 1. We want to get rid of the 3/2 by raising it to the reciprocal power. So I'm going to raise it to the 2/3. The exponents cancel on the left, and on the right, 8 to the 2/3. 2 is the power, 3 is the root. The cubed root of 8 is 2. 2 squared is 4. Or in your calculator, 8 to the 2/3 is 4. You do not need a plus or minus because this is odd. So your answer is just x equals 4. And again, don't forget you could actually plug these back in on your calculator to see if you're correct. So on your calculator, if you did 43 minus 27 to the 3/2, and if you put that in the calculator, you would get 64 to see that you're correct. Okay, trying example 3, which is actually a really great example. We are working from the outside in. Your base is x. That's what's attached to the exponent. 2 is not attached to the exponent because there are no parentheses. 2 is a coefficient. So what we are going to do is we are going to add 4 to both sides. And yeah, if you wanted to, in this case, you could have divided everything by 2 first. And from there, we're going to get rid of the coefficient by dividing. Now that your base is finally by itself, you're going to raise it to the reciprocal exponent. Please just be careful that if your exponent is negative, then the reciprocal is also negative. So I'll put this one in the calculator for us. Notice how, there's a negative exponent here. Negative exponents either create fractions or they get rid of them. In this case, because we don't have a fraction, this is going to create a fractional answer. So our answer is going to be a little odd. We're going to have 4 to the, that was a 5, negative 5 halves. And it's not going to give you a nice answer because it's a fraction. But you can turn it into a fraction by hitting math and choosing fraction. It's 1/32. And on top of that, our denominator was finally even. The denominator represents a root, and in this case, if your denominator is 2, you're taking the second root, which is the square root. Anytime you take an even root, you need a plus or minus. So our answer is truly plus or minus 1/32. For the next one, because this one definitely seems weird, the best thing to do is get rid of the radical. So to get rid of the radical, your power is 1, your root is 3. This is x to the 1/3. Now, we have a fraction, and that's what makes it weird, but I want a fraction. And if you don't want a fraction, well, then include a negative. So we have x to the negative 1/3. And I know it's weird to include a negative in your exponent, but sometimes it is helpful to eliminate fractions for us. From there, isolate the base. The base is x, it's attached to the exponent. So I'm going to subtract 6 from both sides. And then we're going to raise both sides to the reciprocal power. Now, our exponent started as negative, so make sure that your exponent stays negative. -3 to the -3rd power. Now, this will stay negative because negative exponents don't change the sign of your answer. But because we have a negative exponent, we will have a fractional answer here. So if you didn't know it, 3 to the 3rd power is 27. We're going to have 1/27 because of the negative exponent and the negative base. And if you don't believe me, just don't know why, just use your calculator. That is definitely not nice, but you could hit math, frac, to get a nice answer. And of course, your denominator is odd, so you know plus or minus. And I think we are up to the last one. Yes, we are. So given the equal terms, because you know they are equal, set them equal to each other. And regardless of what the rest of the question says, we do not like to work with radicals. So our power is 2, our root is 3. This is x to the 2/3. Now, reading the rest of the question, state state x in terms of y. Because they want you to state x, they want you to get x equals. They want you to get x by itself. So if you want to get x by itself, you need to do the reciprocal exponent. On the left-hand side, your exponents cancel. On the right-hand side, we are multiplying these exponents. So we have 4/5 times 3/2. Now, if you want to do 4 divided by 2, they have a common factor. 4 divided by 2 is 2, 2 divided by 2 is 1. And you don't have to do that, but by doing that, you make it a little bit easier for yourself because now you have 2/5 times 3/1. 2 times 3 is 6, 5 times 1 is 5. Or just multiply the fractions in your calculator, that works too. And if you wrote this, you would be so close to being right, except you have an even denominator. So an even denominator means you're taking the square root, and when you take a root, you need a plus or minus. And there we go. If you still have extra time left in this period, you can do 2 things. If you're feeling confident, try the challenge problems. If feeling super confident, there's a very difficult challenge problem. And if you're not feeling that confident, if you want some more practice to just get down the basics, go scroll down to the additional practice, and there are some extra problems for you to work on.